All right, let's dive into what might just be the single most critical document in any software project, the requirement specification. And I want you to think of this less like some dry, boring document and more like the actual architectural blueprint for everything that comes next.
I mean, have you ever really wondered about this? You see these projects with brilliant engineers, a fantastic idea, a solid budget, and yet they still somehow manage to spiral completely out of control? Well, it turns out the seeds of that failure are usually planted right at the very beginning, way before anyone writes a single line of code.
And here's the kicker. The root of the problem usually isn't technical at all. It's human. It starts in that one meeting, you know the one, where a client says one thing, the project manager hears something slightly different, and the developer, they interpret it in a third way. Everyone's nodding along, but they're all picturing completely different things.
And that right there leads us to the core issue. We try to define these incredibly complex technical systems using our everyday language. But when it comes to engineering, plain English can be, well, surprisingly dangerous.
Here's probably the best way to think about it. Using natural language for requirements is kind of like sketching a brilliant idea on the back of a napkin. It's great for getting a concept across quickly, right? But you would never, ever try to build a skyscraper from it. It's ambiguous, it mixes ideas, it's wide open to interpretation. A structured specification, on the other hand, that's the detailed blueprint. It's precise, it's unambiguous, and it makes sure that everyone is building the exact same thing.
So let's break down exactly why that napkin sketch is such a bad idea. First off, there's a total lack of clarity. Words like fast or user-friendly, what do those even mean? They mean different things to different people. Second, you get requirements confusion. The system's actual function, like process a payment, gets all tangled up with non-functional needs, like it must be secure. And finally, you get this thing called amalgamation, where one single sentence tries to describe 3 different features at once, and it just creates a complete mess.
And that really is the million-dollar question, isn't it? If just talking about it is the problem, then what's the solution? How do we translate what a client is dreaming of into a set of instructions so precise, so clear, that a whole team of engineers can build it perfectly, the first time?
Well, the answer lies in one word: structure. We have to move away from casual conversation and into formal specification. And to do that, we have a toolkit designed specifically to kill ambiguity. So let's check out a couple of the most powerful tools in that kit.
First up is something called a form-based specification. Honestly, the easiest way to picture this is like a super detailed Mad Libs, but for engineers. It's a template, right? It's got specific fields for every single piece of information about a requirement. You literally can't forget a detail because there's a box waiting for it.
And here's a perfect example of why this is so powerful. Look at a simple ATM function. In plain English, you might just say, the user should be able to see their balance. But this form, it forces us to define the exact inputs, account number, PIN, and the exact output, the account balance. See? There is zero room for misinterpretation there.
Okay, so that's great for a simple function. But what happens when a requirement gets more complex? You know, with a bunch of different if this, then that scenarios. Well, that's where our next tool, tabular specifications, comes into play. They just use a simple table to map every possible condition to a very specific action.
And the stakes for getting this right can be incredibly high. For a medical device, say like an insulin pump, ambiguity could literally be life-threatening. This table, though, it clearly and precisely defines the exact dose computation for every possible change in a person's blood sugar. It is the perfect example of how structure provides safety and correctness when it matters most. So we have all these perfectly structured, crystal clear individual requirements. Where do they all live? Well, they all come together in one master document, the Software Requirements Document, or SRD. This is it. This is the official blueprint, the single source of truth for the entire project.
Now listen up, because there is a crucial distinction to make right here. The requirements document defines what the system must do. For example, the system shall allow a user to reset their password. It does not specify how to do it. It doesn't care about the database you use or the programming language. All that stuff comes later in the design phase.
And building this document isn't random. It follows a really logical process. You start by setting the stage with an introduction and a glossary, just to make sure everyone's speaking the same language. Then you move from the big picture user needs down to a basic system architecture, and then finally, you dive deep into those detailed, structured system requirements that we've been talking about.
Okay, so think about it this way. You would never start building a house without having an architect and an engineer double and triple check the blueprint, right?
Of course not. The same exact thing goes for software. Before you write a single line of code, you have to validate the requirements to make sure they're correct, they're complete, and that they're actually achievable.
And validation really just means asking some tough questions, like, are we actually solving the customer's real problem here? Do any of our requirements contradict each other? Uh-oh, did we forget anything? And maybe the most important one, can we even build this thing with the time, the money, and the technology we have right now?
So why is this whole process so incredibly critical? It comes down to this one number, 100. Fixing a mistake when it's just a sentence in the requirements document is pretty cheap, but fixing that exact same mistake after the software has been built and delivered to the customer, well, that can cost up to 100 times more. That is the staggering price you pay for a flawed blueprint.
But of course, we all know the real world is messy. Things change. Business needs evolve, new tech pops up, customers change their minds. A blueprint can't be set in stone. It has to be a living, breathing document. And that brings us to the final piece of our puzzle, managing that evolution.
This whole process is called requirements management, and it's not about preventing change. That's impossible. It's about controlling it. It's a formal process you put in place to analyze the impact and the cost of any proposed change, making sure that every single tweak to the blueprint is deliberate, understood, and implemented properly.
So let's just imagine you've done all the hard work. You've gone from a vague chat to a precise, validated blueprint. You are ready to build. But then the phone rings. It's the client. And they say they just have one small change. This, right here, is where the real test begins. You see, having a solid blueprint and a process to manage change isn't just good engineering, it's about survival. Thanks for joining me on this explainer.